Hello, class. This is one of the problems that I wanted to work for you in video format so that you would have the chance to go through it and you could go through it slowly, stop it and pause it and rewind it as you needed to. So let's go ahead and begin. A dragster covers a displacement of 140 meters in a time of 3.600 seconds. If the final velocity is 53 meters per second, what was its initial velocity? So we start off with given displacement is 140 meters. So we know that. And it takes place in a time of, or a change of time, really, of 3.600 seconds. Part A says if the final velocity is given as 53 meters per second, what was its initial velocity? Okay, so looking at that, that gives us three knowns, one unknown, and then we look at the possible variables that we have. There's one more called acceleration that's not there. So if you use the process of elimination, any equation with acceleration in it, get rid of it. There's only one kinematic that has these four in it. So delta x equals v naught plus v final divided by 2, all multiplied by time. So that would be the only equation that works for those four variables. So the first step I need to do is rewrite the equation so that I'll be able to solve for v initial. So I'm going to multiply both sides by 2, divide both sides by t. So I get 2 delta x divided by t equals v naught plus v final. So I got rid of the 2 and the t. Now I need to move the v final to the other side. So I'm going to get 2 delta x over t, and then minus v final is v naught. Okay, so let's plug in. We've got everything we need. So 2 times delta x, so that's 140, divided by my time, 3.600 seconds. And then I'm going to subtract from that 53 meters per second. Okay, so I'll grab my calculator. So 2 times 140 divided by 3.6 gives me 77.777, keeps on going, minus 53. So I get 24.77777, but rounding to two significant digits, 2 because of the 53 right there, I would round to 25 meters per second. Okay, so my initial velocity for this dragster for this information is 25 meters per second. But that's not my only question. Okay, so let's go on to part B. How far does it travel, talking about the dragster, if it starts from rest and has the same constant acceleration as in part A, ending at the 53 meters per second? So what we're really saying here is part A is dealing with the dragster when it got to a certain velocity from rest. So right here where I've got v equals nothing here, I'm just going to put the 25 here. So my other part A dealt with this part of the problem. What we're looking for now is how far does it travel if it starts off from rest. So let's change color. So now I want to look at the total displacement it has starting from rest if it had the same constant acceleration as in part A and ending at the 53 meters per second. So if I go back a page here, we know that in the change from 25 meters per second to from 25 meters per second to the 53 meters per second, that it traveled 140 meters, right? So this part was 140 meters. What we want to know now is the total length from rest, okay? But here's our clue. It has the same constant acceleration as in part A. So that means we got to go back to part A, and we need to find our acceleration. Now we've got plenty of information to do that. So let me just slide this down just a little bit and see if I can do that from here. So we can take any of the three quantities that we have. Remember, I recommended not to use the value that you're solving for. So if I went with that route, then I've got delta x, v final, t, and a, not using the value that I just solved for. So we could use delta x equals v final t minus 1/2 a t squared. Okay. So using that and using the information that we're given, I'm just going to move things around a little bit. So I get delta x minus v final times t equals negative 1/2 a t squared, because I'm trying to isolate acceleration out of this. Okay, and I think I'm going to have to go to the next page from that. So delta x minus v final t equals negative 1/2 a t squared. Okay, so just writing the same equation down. If I multiply everything by 2 on both sides, so I'm going to get 2 times delta x minus v final t. So that would take the 1/2 out. If I divide by a negative t squared, then I'm left with the acceleration. So before I can even solve for the delta x for the second part, I have to know what the acceleration is for the first part. So I end up with 2 times 140 meters minus 53 meters per second multiplied by 3.600 seconds. And then all of that divided by negative 3.600 seconds squared. Okay, so let's find our acceleration first. So on the top, I get 140 minus 53 times 3.6. And then I multiply that by 2. And I'm going to divide that by a negative 3.6 squared. And I end up with acceleration of 7.8395 but I can only keep in my answer here, I'm going to only keep 2 at the end, so I could keep as many as I want to right here, but I'm just going to work with this as 7.84 meters per second squared. That's not an answer, so I'm not rounding it down to the 2 sig figs just yet. Okay, so now I've got the acceleration for the whole travel, not just for the first part from the 25 to the 53, but from the 0 to the 53. Okay, so now I'm going to do my last part. I'm going to take my V0 is 0. I'm going to take my V final as the 53. I'm going to use the acceleration that we just solved, so that was 7.84. Okay, and I want to solve for delta x. Okay, so I look at those quantities that I'm given. I do not have time involved here, so I want to find the equation that does not have time. The only one that works would be V final squared equals V initial squared plus 2a times delta x. Okay, solving for delta x. So I need to manipulate the equation first. So V final squared minus V initial squared equals 2a times delta x. I've got to get rid of the 2a, so divide both sides by 2a. So I'm left with delta x. Okay, so delta x equals 53 meters per second squared minus 0 squared divided by 2 times 7.84 meters per second squared. Okay, so let's see, 53 squared divided by 2 times 7.84, and that gives me 179, but I'm only rounding to 2 sig figs here, so that gives me 180 meters. So that answered my second question. What is the delta x, which includes the 140 already, starting from rest?